Everyone, welcome back to the channel. So I hope you're doing really well, and in this video lecture we'll be solving this problem, maximum product subarray. So basically we are solving this blind 75 list, and in this blind 75 list we are focusing on the array section, right? So we are solving array problems, and this video lectures go in this video lecture we'll be solving this problem, maximum product subarray. So let's read the problem statement. We are given a integer array nums. We have to find a subarray that has the largest product, and we have to return the product, like the largest product that we have. So the test cases are generated so that the answer will fit in a 32-bit integer. Fine. So what we have to do here is to find the subarray which has the largest product. That is given in the problem statement. Like here in this example, 2, 3 minus 2, 4. In this example, 2, 3 minus 3, 4. What will be the largest product subarray? It would be 2, 3. Why? Because 2 into 3 is 6. Any other subarray, take this 2, 3, like 2, 3 minus 3, this will give me 2 into 3 into minus 3, which is a negative answer. So any subarray which includes this element will have a negative subarray product. So we will not take any subarray which includes this element. That means the only subarray which we are left with, which gives me the maximum product, will be this 2 and 3, right? So think about it, how we can solve this problem. Basically the purpose is to build that intuition, like after you have solved these problems, these blind 75 problems, you must develop a intuition, a pattern, how to solve these type of problems. Like in the previous video lecture we solved the maximum sum subarray problem. This problem is very similar to that, and we used Cadence algorithm. Basically we used two variables, one variable to store the final maximum sum and another variable to basically keep the running sum, keep track of the running sum, right? So the solution will be really similar in this video, in this problem as well, where we have to keep two variables, right? It would be similar. So let's just see this example, 2, 3 minus 3, 4. So since we are dealing with the subarrays, what I'm going to do is I will keep a running product. Let's call it product. Let's call it product. So this is my running product. So initially this contains 1. Now I start traversing this array from left to right, and I multiply each element which I am traversing with this product element. So product is 1, and after I traverse the first element, it becomes 1 into 2, that is 2. Now I move to the second element, it becomes 2 into 3, that is 6. So I also keep track of one more variable, which is max product so far, which is initialized to a very small value. Let's call it int min. So again, the solution is very similar to the solution which we discussed in the maximum subarray sum problem, where we have to keep track of the running sum as well as the maximum sum obtained so far, right? So like in this video lecture, we'll also use the same strategy. The first variable product represents the current sum, current running product, not the sum, current running product, and this max product self so far represents the maximum product of the subarray which I have obtained till a point, right? Now this contains a very small value initially. Why we store a very small value in this variable? This is because we want to maximize this variable. We want to maximize the value which is present in this variable. And that is only possible when we initialize it with a very small value. Fine. Now, this may also contain a negative answer. Fine. This may also contain a negative answer. Remember, all we need is the maximum product subarray which is present in the given array. And now that maximum product can also be negative, but it will be relatively the best product which we can obtain for that particular array, right? So here in this example, the max product so far will be reinitialized to 2 after we have included this element 2 into the current running product. After the first iteration, when we move to the second element, we'll have 6, that is, we'll update the max product so far with this value 6. Then we multiply minus 3 with this 6. So 6 into minus 3 is going to give me minus 18. Right? Now, can we update this max product so far variable now? No, because we have a negative value here. We have a negative value here. So whenever we have a negative value, that means we have included one negative element in the product. Fine. So we'll not update this variable. Now we move to the next variable, which is 4. And now I multiply 4 with this minus 18. So minus 18 into 4, this will give me 72, minus 72 as the product. We again will not update this max product so far because this is a even more negative value. Fine. So what is the maximum product which we have got so far? This variable contains 6, and that is my answer. Fine. I hope you got the solution. I hope you got what we are trying to do here. Let's take one more example to understand it really better. So 2, let's say minus 5. Now take 3, let's say minus 6. Now 9, 11, let's say 40. Let's take this array and try to find the largest product that we can achieve. Fine. So let's say it's minus 9, not plus 9, right? So let's again follow the same strategy. Keep a running sum. Let's call it product, that is initialized to 1. Then we'll start iterating over this element. We'll start iterating over the element, which is this one, 2. So we'll initially this product will have 2. So 1 into 2 is going to give me 2. Now move to the next element, which is minus 5. So 2 into minus 5 is going to give me minus 10. Move to the next element. Now also keep updating that max product so far variable. It was very negative value initially, then it becomes 2, and now it will not be updated in the second iteration because we have minus 10. Then we move to the third variable, which is 3. So minus 10 into 3 is going to give me minus 30. Minus 30, move to this one, into minus 6 is going to give me 180. Now I will update this max product so far variable because we have a greater product. So it will be updated to 180. So up until this point, the maximum product which I can achieve is 180. Now move to the next element, which is minus 9. So minus 9 into 180 is going to give me 4, 9, 1, 9, and 5 is going to give me 14, right? Is it right? No, 1640, right? Negative 1640. Is this a better answer? No, it's not a better answer, because so this is 1620, not 1640, sorry for this, 1620. So 1620, negative 1620 will not update this max product so far variable. Now I move to the next element, which is 11. If I multiply this negative value with 11, this will give me even greater negative value. Again, cannot be updated. Now, let's say that value is x. Now move to the next variable, which is 40. Now multiply 40 with this variable. This will give me even negative value. Again, will not update this max product variable. So finally, this max product variable will have 180 as the answer. Fine. It will have 180 as the answer. So will we, like, do we print 180 here as the final answer? No, we can't do this, because observe this array. Not this. Observe this subarray. 3 into 6 is 18. 18 into 9. So you can see that this is going to give me 3 into 6, 18. 18 into 9, 162. Then we'll have 11. Then we'll have 1782. 1782 into 40, that is going to give me 71280. 71280, if I am not wrong, that is the product of these elements, right? Which is a lot greater, which is a huge number as compared to this 180 answer which we obtained in the previous case. So what is the problem here? What was the problem in this approach which we are using? The problem is simple. We are including elements from left to right. We are not considering elements from right to left, because here we can see that we considered this subarray which gave me a positive answer, and that answer was the highest, but I could not consider this subarray, right? I could not consider this subarray. So that was my problem. So what will be the solution to this problem? The solution is simple. Again, like, use the same strategy from right to left which you used for the left to right. That is, again keep the product to be 1. Now find the running sum from right to left, and now update that max sum so far variable. So in this particular case, we'll have 71280 as my final answer. Fine. So that is the thing. That is the second edge case which we handled here. Now there may be another test case. Let's consider that as well. Let's say we'll have something like 2 minus 11. Then we have 0. Then we have 15. Let's say not minus 11, plus 11. Then we have 2. Then we have 1. Like this. Now keep a running sum from here. 2 product variable initialized to 1. 2 into 11 is 22, right? Now 22 into 0 is going to give me 0. So max sum so far contains 22 at this point. Initially it was 2. Initially it was very small value, then it became 2. Now it became 22. Now the product becomes 0. This running product becomes 0. That means whatever element I will include after this 0 is going to get me just 0 product. It is not going to add any further value into this running product. So will not be, this will not help. So what we're going to do here? This 0 is basically giving me a trouble, because we are missing out this huge product, because the product of these values is 15 into 2 into 1 is 30, which is better than 22, right? So what is the issue here? So let's not, so let's say we have 0 here, 1 here, or 12 here, something like this. So here we move from left to right, the maximum we can get is 22. We move from right to left, the maximum we can get is 12. And maximum of these two is 22. So by using the strategy which we have devised till now, 22 is the answer which we are getting. But the answer is not 22. The answer is 15 into 2, that is 30. This is that particular subarray which is going to help us find the maximum product. So how are we going to handle this case when we encounter 0 at any position in the array? The answer is simple. Whenever we get our running product to be 0, just update it to 1. Fine. Like here it became 0. I found that the product become 0. I will update it with 1. Now 1 multiplied by 15 is going to give me 15. 15 multiplied by 2 is going to give me 30. So again, the product will be 30. So that's how we're gonna handle this test case as well. Okay, I had already solved this problem. That's why I could explain it like this. How you get to know these kind of edge cases. When you solve random new problems, you will devise your solution. Your solution is going to give you wrong answer for some cases. Then you have to think, okay, what can be the test cases? What can be the case where this may go wrong? Okay, you can check out the test case on the Leetcode where your answer got wrong, and now you can dry run your code against that test case. That's how you find out these little edge cases which you have to handle while solving a problem, and this will develop your problem solving skills, because next time when you're solving a similar problem, you will consider these type of edge cases. That is, you'll think about, okay, there can be 0 in the array, there can be negative values in the array, okay, there can be like, what will happen if I move from right to left? Like, you develop these kind of patterns when you solve a new problem. So this is a process. Okay, so you have to follow the process, fine, rather than focusing on the result. Okay, so let's code the solution. So let's take a max product. Now we will use integer variable because we are given that the answer will always fit into the 32-bit integer. Max product so far, initialize it with a very small value. Also take another variable, let's call it running product, which is initialized to 1. Iterate over the given nums array. So I hope this is clear, and I think I should I zoom this, or it's okay? Okay. Let's keep it 20 pixels. I hope this is good. Okay, so I'll iterate over this nums array, product multiplied by it, and now update this max product. So far, max product so far with this product variable. Now if this max product, if this running product becomes 0, then update it to 1. Okay, now finally at this point you will have the max product so far when we traverse the array from left to right. Here we have handled the condition when we encounter 0 in between the array. Now again reinitialize this product to 1. Traverse the given array from last to first element. Nums dot size -1. Product is nums of I. Again, the same thing you have to do. You have to repeat the same thing here. Okay, let's write it. Product so far max of max product so far with the product. If it goes 0, if product goes 0, then update it with 1. Finally, you have to return the max product so far. So let's try to run this solution, and will it is giving me an error because I have an error here. It is giving me an error because I have an error here, right? So let's submit this. Okay, so that's all. This got accepted. I hope you enjoyed the video, and if you do not solve problems by yourself, there's no meaning in enjoying the videos, right? And so you have to solve problems on your by yourself. So keep solving problems, and do let me know your feedback in the comments, how we can improve the content, and like if you like want if you want me to if you want me to you know write the video tutorials, if you want me to create video tutorials for specific section, for specific problems, for specific topic, then please do let me know. I would love to do so. And that's all for this video. I will see you soon in my next video with a yet another problem. And till then, take care. Bye bye.